Okay, the first step in this lab is to measure the resistance of all my resistors. I just put these needles together just to verify that it should be 0. So I have 3 resistors here. They should all be about 1,000 ohms. And I'm going to define them as R1, R2, and R3. Then 195 ohms. Just going to hold it. That must be the wrong size. This is why it's good to measure them. I can't see the colors all that well with my eyes, so measuring them I can ensure that they're the right size. I can if I use a magnifying glass, but let's see. There we go. That one's 980, so I'll call this one R2, 986 ohms. And then R3, gotta find the right size one to use here. See if this is. There we go. And R3 is 995 ohms. Okay, so those are the 3 I measured. I encourage you to measure the 3 resistors you use. The next step is to wire the circuit shown in part 1. And so that circuit is 2 resistors in series that are wired in parallel to one other resistor. So I'm gonna do it. I'll wire this up as best I can here. So I'll put 2 resistors in series. Let's see. I'll go like this. Okay, so that one's in there. And I'll put another one in series with it. Make sure you track which one's which one's your 985, 996, all that. I'm going to be less rigorous about that because I just want to make sure you know how to wire them up and how to make the necessary measurements. Okay, there we go. So these 2 are in series right here. You can see they're in series. Now I'm going to wire one that's in parallel with both of them. And I think I'm going to use a couple little jumper wires so that I don't have to crowd them all onto one little area of the board. So I'm going to put a jumper wire from here. A jumper wire is just I call it a jumper wire, it's just a wire. From there to there. Okay. And then another jumper wire from this other side right here. And I should add, this isn't the only way to wire resistors in this fashion. There's many, many ways to do it that are right, and there's quite a few also that are wrong. You want to do it correctly. You don't want to short circuit anything, so that's the main thing. But you may have another way of wiring it up that's correct also. Okay, so there's my jumper wires. And then I'll put my final resistor in. Here it is. So this goes, one wire goes in the same row as the jumper wire. If I can get it in there. Having trouble seeing here. Okay, it's in the same row as the jumper wire there. That's good. Then the other end is going to go right. There we go. Ah, almost. It's got to get into that same row as that jumper wire. All right, I think I did it. See if that looks right to you. So what I have is this lead of that resistor is connected to that wire because they're in the same row, and same with the one down here. All right, now I need to plug my battery. Well, actually, I'll plug wires in that I can use to measure the resistance. So I'll put one of them here, put the plus one here, and the negative one I'll put that one there. All right, and I'm going to measure the resistance. Let's see what I get. Can you predict what it should be? Hopefully you can predict what I'm going to measure. It's a 2 kilo ohm resistor, which is the two that are in series, in parallel with a 1 kilo ohm resistor. The result should be less than 1 kilo ohm, which it is. It's about 662 ohms. So that makes pretty good sense to me that that's what it should be. Great. Now I'm going to wire my battery up. And how I'm going to do that is I'm going to put the plus side over here. And I'll put the negative side. I'll actually put it, I guess I can put it on the other side so I don't risk shorting anything out. So I'll put the negative side all the way over there. And so the positive side's here, the negative side's there. Then I'll put in my battery. And I'm using my 6-volt battery. It's this guy. And notice I stored it without the one battery there, which is, I told you, a good safe way to do it. So I'm going to put the other battery in. So now it truly is a 6-volt battery, and I don't want to touch my two wires together. But I'll put the plus side right there. Anywhere on this row is fine. And I'll put the minus side over here. Anywhere, I should say, in that column is fine, and anywhere in this column is fine. There, now it's all connected, and then my circuit is working. But you can't tell because resistors don't do a whole lot. They don't glow or anything like that. And hopefully they don't get hot. But I can measure my voltages. And so, how do I measure voltage? The easiest one to measure, I'll do that now, and then we'll measure currents. And I'll remind you how to do that, and then that's what we're going to do in part 1. Hopefully you've predicted what the voltage should be across each of the resistors. So I'm going to set my meter. This is a 6-volt supply, so I'll set my meter so that I'll put it on top of my battery. So it's measuring 20 volts. And I'm going to sequentially put it across each of these resistors. Let's see what this one is. Let me make it so that the plus side is on the side that is positive. So that gets rid of the negative sign there. Looks like 6.3 volts across resistor R1. This one here, what do you think it should be? Let's see if it is what we think it should be. 3.16 volts. This one here, about 3.14 volts. So they were almost identical, those two. One of them is probably slightly bigger resistor than the other one, which is why the voltages weren't identical. Okay, that's how we measure voltage. Now I need to measure current. And I can keep these two things plugged in the same sockets, but I need to switch this over to measuring current in milliamps. And that is, let me see if I can find it. Here we go, right there. There's a 200 milliamp scale right there. How do I measure current? Well, remember, when I measure current, I physically have to break the circuit. What do we mean by break the circuit? I don't mean throw it across the room. I mean I need to lift out one of the leads of the resistor, for instance, like this one. Current's a little harder to measure than voltage. You saw how easy it was for me to measure voltage. I just put the leads of the meter across the thing I was interested in measuring the voltage of. But I just broke the circuit. I pulled the wire out and I pulled the resistor out. And then I fixed the circuit, so to speak, by putting the meter where the connection had been. And I should then measure a current. Looks like I got 3.2 milliamps for this first resistor, which I'll call R2. Okay, 3.2 milliamps. Now I have to fix the whole circuit. So I got to put the lead back in here somewhere. The resistor lead. There we go. And I have to put the wire back in here as well. There, I did that and that. Okay. Now I have to break the circuit at a couple other places. I need to break it up here so I can measure the current going through R3. I haven't done R1 yet. That's this resistor right there. But I did R2. Now I'll do R3. What do you think R3 should be? They're in series, so you probably have a pretty good guess of what it should be. But I'm going to do this anyway. I'm going to break the circuit here, and I'm going to break it there. So it's fully broken. I lifted both leads of these two resistors right here, that one and that one. And I'm going to fix it by putting the meter where the leads had been connected. See what the meter says. 3.2 milliamps. Hopefully that's not a surprise to you, but a pleasant confirmation of what you predicted it would be. So I'm going to put my resistors back in here. That one goes there. This one goes here. Great. I'm in. And I have one more current I need to measure. So I have one more place I need to break the circuit. And that is for this resistor here, which I'll call R1. So I have to lift it up. Then I have to lift up the wire feeding it, which is, let me see. I have to be careful here, because if I lift up this wire and put my meter here, then this part of the circuit isn't going to be seen. So here's what I'm going to do. I'm going to put another wire in here where the resistor had been going, and I'm going to connect those two together like that. If I had connected these two, my circuit would be back to normal. But I'm going to measure my current at the break right there. I have to break just that point there. I can't break it. I can't break this wire off, or else I have a different circuit. I need to make sure that when I fix my circuit by putting my meter back in the place where I'm putting it here, that my circuit will work as it had worked. And I'm getting 6.3 milliamps. Hopefully that's what you predicted that you'd get when breaking resistor R1. If you didn't get that with your circuit, check it over. Maybe talk to me next week, because maybe you broke your circuit not quite right. I broke it. I was very careful to put this wire in to make sure that when I put this back, or that the circuit was the same when with the meter attached as it was previously to me breaking it. Okay, that's the first part of the lab. I'm going to wire the second part of the lab in the next video. I hope you found this helpful for making these measurements of voltage and current for the combined series parallel, the first combined series parallel resistor circuit.